WABYA here. Today I'm going to try to do a quick evaluation of some common plastics. In particular, we're going to take a look at what the attenuation of some microwaves going through the plastics is. We're going to be using a frequency of 24.2 gig, and for our source here we've got a small horn antenna to an SMA adapter firmly attached to the front of the generator. Minus 10 dBm is going to be going in, and it's shooting straight up. For the detector, we've got a small probe coming out of a SMA connector, some microwave cable going down into the spec GaN. I've adjusted the spec GaN so that it's 5 dB per vertical division. We've got it roughly centered on 24.2, and I've asked the spectrum analyzer to display the peak amplitude, and in particular I've asked it to track the peak because there is a slight drifting of the generator and or spectrum analyzer with respect to each other, and that slight drift in frequency, because right now I don't have a spectrum analyzer phase locked to my GPS source, nor do I have the signal generator locked to an external source. They're currently tied up on a different experiment, so they've both been running for about an hour. So there will be some shifting of the frequency, but the amplitude should be fairly constant. It will wander up and down. I've seen as much as 3 to 4 1/100ths of a dB. Like right here, if I'm shooting this as my reference, and I'm averaging 25, by the way. We're averaging 25 samples here. So 43.54 seems to be pretty typical. I've seen that go down to 43.50. So just be aware that the amplitude of the SIGGEN and the spectrum analyzer together as a system whole, like right there, you can see the signal has weakened, and for a second there we hit .57. So what I'm going to do is, rather than trying to tabulate all this, I'm just going to be filming these real time. So for example, let's just call that our reference, 43.58. What I'm going to do, for example, here is a sheet of Teflon. It's 1.5 millimeters thick, and so if we are shooting our reference right there at 43.55 or 54, what I'm going to do is very, very slowly and carefully, I'm just going to lay it right on top. And if we remember, is 43.54. And so it's gathered up its 25 samples, and we can probably get a reading from this point here at 44, call it .42. So we'll call that our first sample test right there. We'll move that out of the way. Next sample is a thin piece of styrofoam. This is off of a common styrofoam plate that you would eat off of. And if we shoot our new reference, call it 53.52 or so, and if we lay it on top like that, you can see it does pretty good. Very, very little attenuation in that small piece of styrofoam. That's pretty impressive at 24 gig. Alright, so let's move that off there. what's our next sample? So here we've got some probably I'm going to guess ethylene. This is from a milk jug. So again, if we shoot our reference, we call it 4353, and if I lay this on top like that, so we go from 50.53 to .84, thereabouts. So there we go, there's the difference there. Ever so slight amount of attenuation going through there. What else have we got? We got a small piece of acrylic. This is I believe 1/16 inch clear acrylic. Let's go ahead and shoot our reference, still holding at 43.54 approximately. And if we just lay that carefully on top, yeah, look at that. So looks like acrylic has a little bit more loss there. Looks like it's gonna average out to about 45. Well, let's call it 18. Alright, let's go ahead and take that off there. What else have we got? Oh, we got some PVC plastic. This is also 1/16 inch thick. And if we took a look at our average here, it looks like it's coming back down. I got to give this thing time after I remove the plastic from the last test. So it looks like 43.55, and I'm going to guess that that's slowly going to drift down, yeah, to 54 or maybe 53. So let's just call it .54 by the time we add that on there. And if I just carefully rest that on there like that, alright, so looks like it's kind of stabilizing. 45, yeah, call it 24. Okay, 23, 24. Potatoes, potatoes. Okay. Next, we've got a piece of Teflon here, very, very thin. This is 1 to 2 mil thick Teflon, and what I'm going to do is I'm going to peel it off of. It's got a sticky back. Hang on. I know you guys are going to hate me for this. I've already gotten all kinds of criticism for the camera moving all over the place. We'll go ahead and try to put this on here. So I got that on there, and we better get our numbers real quick because that might come flying off. But looks like 43, looks like 63, so looks like about a tenth, about 1/10 of a dB. So I've got this sample right here. This is been acid etched ferrochloride, or gosh, I forget the acid, the real nasty stuff. They pre-etch the Teflon so that it has kind of a rough surface, and then they add some adhesive to it. So yeah, looks like exactly, yeah. Looks like just over 1/10 of a dB. Alright, so let's move on to the next sample. We'll take the carefully peel off this Teflon. What do we got next? Okay, so here's just some common plastic. Probably it's shiny and hard. It's off of a fiber container. So whatever that kind of plastic this is, it's hard, kind of shiny. So we've got a reference again. Things have returned to 43.53. And if we rest that on there just like that, now that's a fairly thick piece of plastic too, so I'm kind of surprised there's not more attenuation than what is showing there. So it looks like about 1.1 dB. So there you go. Looks like the plastic that's used for these fiber containers, I'm going to guess that's at least a 1/16 of an inch, what it feels like. Next we've got a Maxwell House coffee lid. Looks like things have returned back to 43. There we go. See, this is the drift that I'm talking about. That's why it's kind of good to get a reference right as we're doing these tests. If I used .53 all the time, we'd be off at least 3 or 4 hundredths right there. So 43, call it 48, 43, 48, and if we rest that on there, oh, I'm gonna have to hold that. It's not working out too good. There we go. You know, I'm not real happy that I've got to move this around. You know what I'm going to do? Let's reshoot this one. So there's our average, 43.52. What I'm going to do is I'm going to set the camera down for a second, and we're going to, there we go. What I did is I've put the plastic, rested it on top of the horn, and while I do have some metal away from the horn holding down that plastic, I don't think it's going to mess up the readings too much. But there we go. It's looking at 44, roughly .2. So, alright, let's move on. What else have we got? We've got a piece of plastic off of a CD case. So this is probably some acrylic, I would guess. Let's let this return back to its nominal value. Looks like 43. I'm going to guess it's going to come down to 55. Yeah, so let's just call it 43.55. Alright, and we'll rest that on there just like that. Look at that, almost exactly 1 dB. Yeah, close enough for government work. We can call that 1 dB. Alright, what else have we got? I do got a piece of, I'm going to have to look this one up. This is a piece of very thin, maybe Lexan that came in. I'm going to have to peel off, I'm going to have to cut off a sample and then peel off the protective coating on both sides, and then we'll throw that on there. So I'm going to have to stop this recording and cut this, put it on there. So we'll be back in a few minutes. Alright, so I found a few more samples to play with. I'm kind of surprised the reference level is still pretty close. So let's use 43, call it 57, 43, 57, 58, oh, there it is, 59. I spoke too soon. Well, anyway, you can call it whatever you want. It could just be me moving through the room here. I try to sit as still as possible and let things average out, but okay, let's call it 55. 43, 55. This is polycarbonate. That long big sheet that I had was 1/16 inch polycarbonate. So we had 43, 55. Let's see what it ends up being. Oh, look at that. It's pretty high. I wouldn't have guessed that. Call it 4513. There's something that I need to mention. When I was doing a little bit of research on these different plastics, even something as innocent sounding as polycarbonate, there are no less than 100 varieties of polycarbonate. The chemistry that goes into this varies by the company that makes it and the application that it was made to do. There's all kinds of ultraviolet inhibitors and stabilizers and different polymers and stuff that they get added to these plastics. A given company can have dozens of different types of grades of clear polycarbonate like this. So, you know, tests like what I'm doing here kind of are useless because the plastic that I'm testing here may be totally different than the plastic you're going to be testing or using on your antenna. So this is kind of, it's actually pretty useless, but interesting. So just keep that in mind. You can look up a given company, a different plastic company, and like I said, I did some research on this, and literally I found some stuff online, and there are just thousands of different types of plastics. There are handbooks made for different chemistries that go in to make different plastics. So this just happens to be this particular one. Fortunately, I know what company made this, and I know the trade name that went into this plastic and things like that. So for my own use, when I bought a lot of these plastics off eBay, I was able to get a name and a model of the plastic. But you know, when you are at home and you say, geez, I'm going to get a piece of polycarbonate 16th inch thick, it may have all kinds of ultraviolet inhibitors, it may not, it may have stuff to strengthen it or keep it scratch resistant, you know, make it weatherproof or make adhesives stick to it better. There's just countless varieties of different plastics available, so keep that in mind. One thing I thought would be interesting is I pulled this off an L&B, and it's unfortunate that it doesn't fit over this horn But if we go ahead and shoot our reference, so there's 43, call it 50, 51, 52. I'm just going to lay it on the top like this. Unfortunately, I can't help but get some of these ridges on here, so this may not be a real fair test, but this anyway was off of a approximately 10 gig LNB, you know, for commercial satellite use. I just plucked it off. So there we go, 4473. So yeah, call it 1.2 dB. But again, where some of the edges, this round ridge is hitting some of the edge like that. So not really a fair test, but just threw that in there just for fun. And then I've got some unknown microwave absorber. This ought to be interesting. I'm going to leave the backing on it, so you're supposed to peel that off and it'll be sticky on the other side. I'm going to leave that paper on there, so this is going to be just for fun. So 43, let's call it .5, and we'll put that on there like that. Oh geez, look at that. Who would have guessed? It's falling like a brick. Like I said, I don't know the frequency range of this absorber, but I'm sure it's loaded up with all kinds of carbon and maybe even some ferrite material in there. So looks like it kind of stabilized. So call it 62.04. Alright, so that was fun. And then for the last one, we just got a simple little plastic bag. It's kind of like a Ziploc bag. And I'm just going to put, this is 2 layers. So there we go. That's just resting on there. 2 layers of just a thin, cheap plastic. And we were looking, I guess we could use the reference of 43.5. So there you go. Look at that. Virtually no absorption through 2 layers of just cheapy cellophane plastic. Let's see what it shoots up to. Yeah, there's 43, 52. So, man, you know, in a pinch, gosh, take a couple of layers of this, put a rubber band around it, and you could probably call that good and wouldn't cost you a penny. And not sure how resistant this would be to ultraviolet, but I'm gonna guess this would probably last at least a year out in the environment like that, unless you get some crazy hailstorm driving hail in sideways or something that might puncture it or whatever. But man, that's pretty impressive. So alright, I can't think of any other. I wish I had someplace I had some FR4, and I've also got some other printed circuit, some fiberglass, but I can't seem to locate it, so my apologies for not being able to test those. But anyway, I hope that you found this interesting. If anything else, 73 W8BYA.